Hi students, welcome you all to my channel Physics Philo. Today we discuss the physical significances, divergence, curl and grad. I will ensure you after watching this video you will have a solid idea about the divergence, curl and gradients. So let's discuss. Before going to know this divergence, gradient and curl, we should know what is the scalar field and vector field. So here I have given a beautiful example for you. Here you can see this is an aquarium. It is full of water and fishes are there. Suppose if you are pouring more and more water from this aquarium, the water will overflow and it will be spread out in all the direction from the aquarium. When water will come out, as well as the fish, those are in this aquarium, they will come out. So now you just think when water is coming away, then you can find more water will fall near the aquarium and less water it will be spread, it will be fall in the away from the aquarium. The water will fall, but if you see the fish, when the fish will fall from the aquarium, they will try to move. So when you observe after overflow of this aquarium, you can find some water falling here near, some water far away, some water far away. In this side also, in all the sides you can find the water amount is there. So what does it mean? Here water also there, it is spreading away from the aquarium, but this water has no direction, it has some magnitude value. Like you can see, suppose near the aquarium there is some high amount of water, it may be 50. If you go away, the amount of water is decreases. But this amount of water doesn't have a direction. That means the spreading out of the water from the aquarium, it is distributed in the space in the different amount, and it has no direction. The amount of water around this aquarium can be compared with the scalar field, because if you go away from the aquarium, you can find some magnitude is there, some amount of water is there, but it doesn't have a direction. But if you compare the fish those are coming away, they will stay at a place, positions, but they will try to move. That means we can find some fishes are here near the aquarium and they are moving in some direction. And some fishes that are away from the aquarium, they are moving in other direction. If we compare this, you can see here, suppose the 10 is the magnitude, the fish is falling here, magnitude is 10, it has some direction. And the fish which is away from the aquarium, suppose it has a different magnitude and it has a direction. That means we can say the spreading out of water from the aquarium can be compared with a scalar field, but the coming out of the fishes, those are spreading away from the aquarium and they are moving in the different directions, we can compare it as a vector field, because this fish has this magnitude as well as the duration. But in this case, when we discuss the divergence, curl and the grad, we have to know about the del operator. It is a mathematical operator, but it has its separate direction. Its direction is x-axis, y-axis and z-axis, and the interesting part is the del always want how the quantity is changing with x and y and z. The del always want how the changes are happening with the physical quantities in x, y and z direction. This del operator can operate in the scalar field A and vector field phi. When it will operate the vector field with a dot, we call this a divergence. When it is operated with a vector field with a curl, we call a vector field with a cross product, we call it a curl. And when it just normally operate with a scalar field, then we call this is grad. And to understand these things, the dot product, cross product and this the simple product, we have to just think about the some physical quantity is work done, which is force into displacement. Here what is happening is a dot product, but also dot product. But F dot ds means it is Fs cos theta. That means which component of force is along the ds. Which component of force along the ds, it will give you the work done is energy, and energy has no direction, it has also the magnitude. Then you can say energy is a scalar quantity. And here you can imagine what part of force it is along the direction of the displacement, it will give work done. Similarly, when we are operating the del with a vector quantity, that means I cap del by del x of, if you will write the component form, suppose x, then it will give you which part of this A vector is along x direction, which part of this A vector along y direction, which part of the A vector along the z direction. Like the work here, whatever you will find, it don't have any direction like the energy, but it will have some amount. Therefore, we are calling the divergence of any vector is just curve. Similarly, if you come to this cross product, you just imagine when you keep a charge of amount of q and it has a velocity v in this magnetic field. When you are putting a charge q, it is moving in the velocity v in the magnetic field, then the force acting on the charge due to the magnetic field is F equal to q whole into v cross v. What does it mean? When the charge will move, suppose charge will move in this direction and suppose your magnetic field in this direction, charge is velocity is this direction, v is this direction, then your cross product will be v to b. That means the direction of the force will be perpendicular to the plane. So when it will come out in a field, here also you can find some velocity is in this direction, and if the velocity is this direction and your magnetic field, your velocity is this direction and magnetic field is this direction. Again if you find, then from v to b you will go, then this vector, resultant vector will be in this direction. That means if you make a cross product and if you find step by step, it will look like it is a rotation. First it will come in this direction, then it will come in this direction. If you do, then it will come in this direction. That means when you are doing a cross product, the resultant is coming like a rotation of vector or curling of vector. Therefore, in the del cross F, it is giving a vector quantity and it will have some magnitude. It is only the direction, it has some magnitude as well as the direction, and if you compare with this F equal to q whole to v cross v, then you can find these vectors are just rotating. Therefore, del cross A we call it a rotation or circulations. But in case of divergence, when you are finding out what is the change of A vector in the x direction, what is the change of A vector in the x direction, that means if you are moving away from the source, then how this A vector changing? Whether this amount is increasing or it is spreading out, or it is slow, it is rest, or it is coming in, that things we can find from divergence. It is just a value, and you can say how this amount is spreading out from a particular source. So divergence gives the concept of spreading out, but the curve giving the concept of the circulation or rotation. And if you consider this gradient, it is just a normal operation with del with the phi, but as del is a vector quantity, then you will find phi also a vector quantity, because phi is a scalar, but when you operate with this, then as it is a vector quantity, then the resultant will be the vector. So how we can discuss these things if we consider the potential, electric potential or gravitational potential. So here this is the R, and you can find these are the gravitational potential. The R, if you come to the some distance, then in this point, in this point, in this point, you will find some potential value, gravitational potential value. If you go away, then you can find the gravitational potential value is decreasing. But when these points are operating with the del, that means it is showing how the gravitational potential is changing, how the gravitational potential is changing in the x direction. Then if you find in this point there is a gravitational potential, but if you going towards Earth, your gravitational potential is increasing. Therefore, gravitational potential is scalar quantity, but how it is changes when you are seeing changing, that means it is increasing towards the Earth. So when you are talking about increasing towards the Earth, that means it is taking a direction. That means the magnitude is increasing, but increasing towards the Earth. Therefore, the potential is a scalar quantity, but when you are operating the del, it is giving a direction and it is towards the Earth. Let's discuss the divergence. If divergence is 0, that means the spreading out is 0. That means nothing is spreading. When divergence is positive, it means your more and more quantity is flowing away. That means it is you are near the source. you can understand these things with this example. Suppose this is a tap, here water is flowing. So if you find the divergence here, then you can find at this point the vectors are going away. That means you are near the source. And when this flowing is coming, so water is flowing and it is a basin. When the flow will here, then near the basin, near the sink, you can find there is a rotation. Means this water it is rotating and finally it is going down the sink. That means in the sink all the vectors they are converging in the sink. Therefore we can say this flow it is spreading out is a divergence, and when it is getting into, that means when the converging, there also you can find divergence value. This is called the sink and the divergence negative. So here divergence is positive as it is going away, but when it is entering, all the vectors they are converging towards a point, there it is a negative, and we are calling the sink. This is the concept of divergence. When this is positive, source near the source, negative it is sink, and if the divergence is 0, that means the vector is not moving and it is a steady state. Similarly, when call is 0, we know from this example, call is nothing but the rotation. When call is 0, that means the rotation of this vector is 0, that means it is not rotating, it is just stagnant. Therefore, we call the irrotational. But when call is positive, and we know from this example how the things is moving, when you are getting call positive value, that means the rotation is happening with the counterclockwise direction. If this is clockwise, it is positive, it is counterclockwise, and is negative, this rotation is clockwise direction. And in case of grad phi is 0, that means there will be no changes. That means like equipotential surface, all this potential is same. That means you won't find any increase or decrease of the potential. So in this direction, if you make the divergence, you will find a constant value. In this case, if you find this gradient, we will find a constant value. But where if you consider this gravitational potential, if towards the earth the potential is increasing, that means if you moving away from the point and you are getting the gradient is increasing, that means potential value is increasing. If it is move away, means it is increasing value, and this negative when you move away is a decreasing value. So when you are coming away from the earth, then your potential will decreases. So if you find the grad phi along this direction, then you can find the magnitude value is decreasing, but there is a particular direction. Therefore, there grad phi is negative, and we can say here the magnitude value is decreasing in the direction where we are considering is del by del x. The x direction, the magnitude decreasing, y direction, magnitude decreasing, as well as in the z direction, the magnitude is decreasing. I hope all you people understand what is the concept of divergence, call, and gradient. Thank you very much.